An engineering project, from the generation to the operation of a plant or machine, is generally composed of the following four main phases: planning and configuring, implementation and module test, testing and commissioning, operation and maintenance. The commissioning staff receives the plant software from the project planner or the programmer and must commission the plant safely, efficiently, and in due time. The Sematic software gives you optimum support in the testing and commissioning phase with practical testing tools and diagnostics functions. We show you the commissioning process for a plant component as an example and introduce you to the Sematic Manager functions. The commissioning process can be divided into several activity phases in which various testing and commissioning functions are used. During the visual hardware check, completeness and installation of the automation devices are checked and subsequently switched on. The display elements on the modules give you the initial diagnostic information. While commissioning the hardware of the automation devices, it is mainly the parameters and wiring of the modules that are tested using the editor of hardware configuration. In the software commissioning phase, the functions of the user program are tested with the support of the Sematic Manager. In the following, we give you some examples of how to make integration testing and commissioning simple and efficient using the convenient tools. The core area of hardware commissioning is the provision of the automation components with the correct parameters. Furthermore, this phase comprises wiring and signal testing of the process I/O. Normally, the hardware configuration is already generated by the programmer in the implementation phase. However, it can also be corrected or supplemented online during commissioning. Our first commissioning task involves establishing a connection to these two automation devices. The programming device is connected at the Profibus, and the Profibus station addresses of the automation devices have been set according to the plant configuration. After switching on the supply voltage, the LEDs at the front of the CPU indicate the operating mode. The power is on and the CPU is in stop mode. The Accessible Nodes function of the Sematic Manager shows us all the modules accessible at the bus system and their addresses. This gives you a quick overview of which bus stations are already accessible with the programming device. This allows you to easily trace a faulty station configuration and correct it. For loading the given hardware parameters and configurations into the CPU, we open our project in the Sematic Manager, select the station and open the configuration by clicking the hardware icon. The editor of the hardware configuration shows the rack with the modules in the upper window and the detailed information of the modules used in the lower window. Here you can, if necessary, make changes to the parameters or the configuration via the integrated hardware catalog, such as exchanging or adding modules. The transmission of the configuration data from the programming device to the CPU is triggered with the Download to Module button. After switching on, during the startup, the CPU compares the configured setpoint configuration with the actual configuration. In our example, the CPU is programmed to immediately change to stop mode if there is any deviation. In this case, it is a definite indicator that the actual hardware setup differs from that specified by the project planner. With its detailed diagnostics options, the Sematic Manager shows a quick overview of the causes of the CPU stop and subsequently offers you a detailed error analysis. In the window for diagnostic interrupts, you see that the stop cause is a configuration error of channels 0 and 1. From our configuration documents, we know that the connected sensor supplies a current value of 4 to 20 milliamperes. For channels 0 and 1, the measured range ±10 volts is the wrong default setting. In the offline project, we correct the measured range, save and compile the change configuration. Subsequently, we retransfer the configuration and start the CPU. The CPU remains in run mode and there is no longer a diagnostic interrupt. The mechanism for loading and testing the hardware configuration is the same for all automation devices, and therefore also applies to the Sematic S7-400 of our example. In this early phase of commissioning, the Sematic Manager supports you in assuring a correct hardware configuration.